This is Dr. Carroll. Today's video is about STL algorithms. Okay, so as a little background refresher, there's three main STL terms. There's the container, things that hold objects. There's the iterators, and that's how we cycle through each of the elements. And then there's algorithms. So more specifically, an algorithm is, at least in the STL algorithm, is a collection of functions that are designed to be used on ranges of elements. And by ranges, we mean a sequence of objects that you can get access to either by an iterator or actually by a pointer. And you can work on them with a very huge range of containers. These are available through the algorithm header file. So you pound include algorithm and you have a wealth of options. Just to paint a picture of some of the things that are available, some of the more common algorithms deal with sorting. If you don't want to, you don't ever have to write a sorting algorithm again, as long as you have an STL container. Searching, inserting, deleting, shuffling, reversing, copying, finding the min or max, or both actually, which you can imagine could save time as you're iterating through, find both at once. Counting, taking the union of two containers. That means finding what is common between them, or alternatively finding the intersection. You don't have to write any of this code. With one line, you can say, hey, start from this range, and end at this, start at this element and end at this element, and iterate through this range, and then there you have it, and it'll do it for you. Let's look at some examples to make this more concrete. These examples are available online. All right, here we have the algorithm examples count code available from the chapter 3 directory. We have some pound defines just to specify the largest number and the largest num. What we're going to look at here is the function count, and its prototype looks something like this. We have a first iterator, last iterator, and then we're going to pass in the value. So let's take a look at the main here. First, we're going to do this with vectors. So here's our type. It's a templated vector with type ints. We're going to seed our random number generator, and we're just going to keep adding them on the back, some random numbers, just something to play around with. And then we're going to get another random number here of what to look for, a query in the container. And then we call count here, which is specified as the tool type suggests from the algorithm in the algorithm header, and we tell it the iterator to where to begin and the iterator for the element past where we want to end, so the end, and then we give it the query, and then we're going to print out how many times how many occurrences there are, and we'd expect somewhere the max divided by the largest num. It's random, so it's not going to be exactly that. Additionally, when you see it run, I use this example to illustrate that it also works with pointers and on a simple array. So don't just think the algorithms are just for the STL containers only. They can be used on other things as well. So here we have a character array with some letters here. We get the size of the array by saying, well, how much memory does it take and how much is each element? Okay, that tells me how many elements are in there, so that we can do that with the range. I just picked a random query here, or maybe not so random. And then here at count, we give it a pointer, because arrays are really pointers. So we give it a pointer of where we want to start. We give it a pointer of where we want to end, the start plus how big it is, pointer arithmetic, and then what we're looking for. And it's going to count that as well. Okay, let's see it run. So 2 appears 83 times, and we're expecting around 100. And S appears 2 times, which is right if you look at that array. Let's run it again. So this time 0, we're picking that randomly, appears about 97 times. That's what we'd expect. Okay. Make sure it's working correctly. 6 appears about 92 times. This is looking correct. Okay. So let's get another example. This is the algorithm example sort. What we have going on here is we're going to use a deck, and we're declaring a deck with random characters. We're going to put in each of the characters A to Z into the deck. We're going to push them in, and then we're going to randomize their contents by using random shuffle, which is available from the algorithms header. And then we're going to print out the values. We'll sort the values and then print them out again. Okay, so that we know that it's sorting. We're also going to use a C++ range-based for loop here, where you declare your temporary variable, a colon, and then the container which you want to iterate on. It's going to go through each one of these and copy that into our temporary variable here. We can print it out. Very nice and concise way to write a for loop that's available in C++11. On Ranger, you'll need to use the -std equals 0x to be able to get this functionality. And then look how easy sort is here. We tell it, hey, we want to sort from here to here, and we're done. It sorts it. And then we're going to use an iterator here to print them out. Just for variety, we could have copied and pasted this and it would have worked just fine. But we're going to, the iterator, we set it to the beginning. We go until it doesn't equal the end, and then we print it out and we dereference the iterator. Okay, so that's what we have going on here. But look how easy that was to randomize it and then to sort it. One call does it all. Okay, so here we have our random letters from random shuffle, and then here it is sorted back again. If we run it again, though, interestingly enough, we get the exact same random shuffle, which may be what you want, maybe not. You can actually give it your own randomize method. Okay. All right. That's what we have for today.